So this question is asking us to provide an acceptable systematic IUPAC name for this molecule. And this is like the typical kind of question you'll see when you first learn nomenclature in an organic chemistry class. They usually teach you about naming alkenes and different functional groups as you learn about reactions that involve those types of molecules. So this is about as complicated as it's going to get on like your first organic chemistry exam. So to start these types of questions, you just need to first find the longest chain, which is called the stem chain or parent chain. So you just kind of eye it out and then count. So you can see if we start here, we'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we start here, we'll get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's longer, so that's obviously not the parent chain. And you see that if we start at either this carbon or this carbon, we'll still end up with 12 carbons in the parent chain because this will be the third carbon when counting. So it would be like 1, 2, 3, and then to 12, or 1, 2, 3, and then to 12. And when you have a tie for the longest chain, you choose the one that has the most substituents on it. So if we started with this as carbon 1, you'd see that we would end up with 3 substituents. We would have this as a substituent, and also this group, and then this ethyl group. But if we start with this carbon or this carbon, which are pretty much the same when we're talking about nomenclature for this molecule because of the bond line drawing, because we can just rotate around this bond, and then we would end up with the same thing. So it doesn't matter which carbon we choose here. So if we do start from one of these carbons, we'll end up with 4 substituents. We'll have this first methyl group, so we'll have 1, 2, 3, 4. So this is we're gonna include this carbon in the parent chain. So I guess I'll just kind of scribble it, and that has 12 carbons, which is a dodecane molecule. And the next thing we need to do is figure out which carbon is going to be carbon 1 and which carbon is going to be carbon 12. So we want to choose carbon 1 so that our first substituent is on the lowest number possible. So you see that if we have this as carbon 1, we'll have this methyl group on carbon 2. But if we have this as carbon 1, we'll end up with this ethyl group on carbon 1, 2, 3, 4. So this is going to be carbon 1. And this right here is going to be carbon 12. And the next thing we're going to do is just start listing off these different substituents, and then we'll put them all together into the full name once we have them all listed out. So on carbon 2 we have a methyl group. So in the final name it's going to be listed as 2-methyl with a YL because it's just a single bond. And on carbon 1, 2, 3, we have a ethyl group, which has 2 carbons, again with YL. I don't know why I put that dot there, but yeah, 2 carbons, 1, 2. Don't make the mistake of thinking this is a propyl group, because it kind of looks like that, because we only count the carbon that's attached to the stem chain. We don't include the carbon that it's attached to. So it's always just 1, 2. And this group here, it's going to be on carbon 1, 2, 3, 4, 5, 6. And because it has this extra branching, it's what's called a complex substituent, which gets put in parentheses. And we always have this carbon here that's attached to the main chain as carbon 1. So we see that we have 1, 2, 3. So it's going to be a propyl group. And that's going to be the suffix, again with YL. And we need to name the substituents that's attached to this propyl group, just like it was a molecule of its own. So we have a chloro group on carbon 1, and we have a methyl group on carbon 2. 2-methyl. And then I'll just put these all together for this the substituent, and we list the substituents by alphabetical order of the first letter. C comes before M, so 1-chloro. dash 2-methyl, another dash there, and then no dash propyl. So this is for the complex substituent. Don't make the mistake of thinking that you write propane because it's just a complex substituent, but you do not put a dash between the base for the complex substituent. Hope that made sense. Okay, and we also have on carbon 12, 11, 10, 9, carbon 9, we have an ethyl group again. And now I'm just going to put these all together, and we go by alphabetical order. See, we have 2 ethyl groups, so we're going to end up with a 3, 9 dash diethyl, but we're just going to go by the E. We don't count the di or tri or whatever we end up with. So I took care of these. Okay, so we go by alphabetical order, so we have C, E, and also M that we need to worry about. So of those, we have C comes first, so I'm just going to write that out. 6 dash. Okay, so we have chloro taken care of. We also took care of that. So next up we have the diethyl. So we put in a dash to separate the different substituents. And 3, 9 dash diethyl. Wow, that's a long name. And then we put another dash to separate. And our last group is 2 dash methyl. 2 dash methyl. And then because we have 12 carbons, it's a dodecane, so no dash. See if this fits. Dodecane. Just fits. Alright, so this is the name of this molecule.